Hello, my name is Dr. Mark Coleman and I'm the admissions tutor for the Materials Engineering Department at Swansea University. I thought I'd put this presentation online. This is a presentation I normally give to prospective materials engineering students during open days. However, with the difficulties we're all facing now in getting out and about, I thought I'd put this presentation online just so that you have a flavour of what happens at Swansea University's Materials Engineering Department and some of the things that we're getting up to now. So a little bit of background about myself before we start. I studied Materials Engineering at Swansea University a while ago, and I studied in the Singleton campus, where I then stayed on to do a master's and a PhD in research. And then I went on to do about an 8-year research career, and I worked for companies such as Cummins Turbo Technologies, Rolls-Royce, and a project with EDF Energy. And now I'm back in the department, and I now teach as a first-year lecturer. I teach undergraduate students. I teach quite a lot of students. I teach between 500 and 700 students, which I'll talk a little bit more about later on. So if you come to the department, then I get to teach you next year. So a little bit of background about Swansea University, if you don't know. We're actually celebrating our 100th year this year. And when we were set up in the 1920s, we were set up by the Vivian family as there was a need for metallurgists at the time. So metallurgy and materials engineering actually kind of go hand in hand. So arguably you could say that the materials engineering department is the oldest department in the university. And we've been going strong ever since, and we have quite a rich history, and we have quite big collaborations still with industry, which I'll explain a little bit later on. So if you don't know what materials science and engineering is, then you're not alone. A poll of sort of sixth formers and college students shows that they can describe what an aerospace engineer does, or what a civil engineer kind of does as well. But the materials engineering discipline is not as well described or not as well understood. And essentially materials engineering is the study of the structure of a material and then how that affects the properties of the material and how you can control one from the other. And so you can see straight away that it underpins all of these other disciplines, because everything's got to be made from something, right? So whether it's a polymer, a ceramic, or a metal, you have to understand how to process these materials and how to get the best out of them. It just so happens that in Swansea University we have quite close links with companies such as Rolls-Royce and Tata Steel, and so we end up collaborating with a lot of aerospace and civil mechanical engineers anyway. So it's very much the whole College of Engineering itself is quite a collaborative department. But I think materials science as a whole has the benefit in that it underpins a lot of these other disciplines, and so it's a great subject to choose if you're one of those people like I was when I was a student that wasn't quite sure what they wanted to do, maybe sort of when they grow up. So because it underpins a lot of these other disciplines, you can specialize later on then in the steel industry or the polymers or ceramics, or biomaterials, aerospace, or whatever you want to do afterwards. So it's a great discipline to choose if you're a bit undecided still. Okay. So this is a description of the academic routes. You can see in the center here, there's your BEng, your Bachelor of Engineering. That's kind of your standard 3-year course, where you've got year 1, year 2, and year 3, and then you'd finish with an accredited degree. You've got the option in the BEng to do a year abroad or a year in industry. These are normally sponsored by a sponsoring company, an industrial company, where you end up essentially working in a placement with them for a year. And the feedback we get from this is fantastic from both the students and from the sponsoring companies. So we use a lot of the feedback that we get from the sponsoring companies to help us modify our courses to produce students that do well in the working environment. So as a result, our employability scores are quite high. You can decide straight from the bat if you wanted to do a master's course, where you can see the MEng there on the right. You essentially do a 3-year bachelor's of engineering, and then you've got your 4th year just at the end there, the level M. So there's a taught master's year where you get the extra award at the end of an MEng. And right at the start as well, you can see year 0. Swansea University, we also offer a foundation year. So God forbid, especially in this environment, if your standards of A-levels, college work, if you haven't had a chance to even complete your studies, and you're not quite meeting the entry criteria for the course, then you can come on to the foundation year, and you will have a year preparing for your BEng, and you will be covering things like basic chemistry, basic maths, just to get you up to speed, and normally then you start the first year ahead of your classmates actually. So what we find is students that start on the foundation year, they do really well. You're already working in the university environment, you have a good discipline in how you work, and you're used to the lecturers, and so we have a really good feedback from students on the foundation year. This was the sort of course structure for the year. Obviously everything's up in the air now at the moment. Normally the year is split up into 2 semesters. Sort of September to Christmas semester, where you get exams in January, and then the February to the summer semester, where you get exams then at the beginning of the summer. That's up in the air at the moment, so keep an eye out for how we're going to adapt to the current situation and what we're going to do from there. This is an example of what a materials undergraduate modules look like in the first year. So I think I'm on here somewhere. I'm on semester 1. There's me, EG 180, Introduction to Materials Engineering. You study 120 credits for the year, and you can see there's a sort of gap down at the bottom. That gap there is a choice that you guys get to make. So you can decide to fill a module in there from the 3 on the right hand side: engineering sustainability, foundation chemistry, or engineering science. That's like a maths module. So materials science and engineering, like I mentioned earlier, is quite a broad subject, and we're quite flexible in the entry requirements to our course. But what that means is we get quite a broad range then of people with different strengths and weaknesses from who have studied different things at A-level or college. Okay, so that's normal. Not everybody takes A-level chemistry. Not everybody does maths modules. So there's an option here for you guys then to decide, well, what do I need to work on? What do I need to sort of brush up on? And so you can pop foundation chemistry in there, for example, if you know chemistry's a little bit weaker and needs some work, or you can do the engineering science if you want to strengthen up the maths a little bit more. Okay, the actual year itself is a mixture of taught modules in sort of lecture halls and then lab classes. So you can see on semester 2, that one there at the bottom, EGA 113. That's a case studies module. That's really fun. We take a lot of what we've done in our classes and we apply that then in the labs, where we look at like failure analysis, or we do like a case study where you guys have to sort of use all the knowledge, use a little bit of detective work, some of the instruments that we have in the department, and then apply that to like a case study and then write a report. So that's a great way to finish off the semester, and it's a lot of fun as well in class. So this is a typical example of a timetable for the week. You can see you're working most days, unfortunately, and you're expected to do sort of 15 to 18 hours of lecture a week, and you should be doing a couple of hours as well at the end of each day at home or in the library on campus. You can see Wednesday afternoons in the week there that they're sort of kept free. That's for you guys. That's to make sure that you've got a chance to play sport, you've got a chance to attend any social clubs that you've joined when you were in Freshers Week. And so we sort of tend to leave you alone Wednesday afternoons if you're involved in the athletics union and play a game, football, rugby, lacrosse, hockey, whatever. There's something for everyone. While you guys are off having fun, normally we're having staff meetings at that point. So it talks a lot about the first year. In the third year, in your final year, you'll be expected to do a small dissertation. And normally this is research kind of based. Now the dissertation project in the third year is very important because you have to have, well, for a start, it's worth 30 credits, right? So that's a quarter of your final year mark. So it's quite a big chunk of your final year. So if you do really well in your dissertation, then you'll do hopefully do really well then in your final year as a whole. So we target the dissertation projects in particular in the materials department, and one of our strengths is that we have a lot of links with industry. And so a lot of our third year dissertation projects are sponsored by an industrial partner, whether directly sponsored or indirectly sponsored by tagging you on to someone's like PhD project. You will be working on a live project. You will be working on like a current engineering problem. You'll get hopefully a chance to work with companies, get a chance to tour their facilities, and they can come to the department and work with you. So for that reason, we normally have a fantastic feedback rate from our students that do our third year dissertation projects. And you can see there's just a selection of some here. You've got some sort of standard metallurgy ones, which you'd expect to find in the materials department, where you're working on automotive steels or something like that. Quite a lot of aerospace projects. We have a bit of crossover actually. I'm actually sponsoring 2 aerospace students at the moment this year, because we have a big Rolls-Royce testing facility on campus, so it kind of lends itself to sponsoring dissertation projects. The energy for materials projects, this is quite a growing topic at the moment, where we've introduced new modules in our second year as well in particular. So you can work on photovoltaics. We have a big photovoltaics department and battery technology department at Swansea called Specific. Definitely go and sort of Google them if you like. They're fantastic. Their remit is to turn buildings into power stations. So we've got 2 examples of that on campus, which I'll put a link maybe at the end so you can see what the specific building is. So if you want to work on battery technology as well, that's obviously a growing area of interest at the moment. There's a chance to do that. Oh, I mean, we've got loads more. We've got a big composites department. The corrosion and coatings is its own department as well. And then you've got things like bio-inspired materials projects, which is quite a growing area of interest as well. So it kind of, just by looking at those projects, you can see what I said at the start is we're quite a broad range of topics, right? So you can work on any kind of discipline that you like at the end. At the end, you will get an accredited degree. So our materials engineering degree is accredited by the IOM3, which really helps you then if you wanted to go ahead and get chartered status along the way. And if you wanted to become self-employed or start up a consultancy firm later on, then this is a real help at the start. So just a brief little bit of background about the learning and teaching culture in the engineering department as a whole. It is fantastic, okay? We place a lot of emphasis on the quality of our teaching, and for that reason we have a TEF Gold award, which is the highest standard you can achieve for the Teaching Excellence Framework in the UK. And we have a mix of teaching styles. Okay, like I mentioned earlier, you might be doing some lab classes, group work, standard sort of chalk and talk lecture material. We do blended learning, e-learning, flipped learning. It's a fantastic mix of content that you can get now. So we place a lot of emphasis on the quality of our teaching, to the point where feedback from students is taken very seriously. So you get a chance to do 2 lots of feedback every semester, a mid-module and end of semester feedback. And we take these very seriously, to the point where this is actually now linked to our promotion. Okay, our teaching output and our scores on our teaching is linked to our career progression. We have a big student support family at the College of Engineering. We have a massive team that are dedicated to just help you. If you're having any problems or with finances, accommodation, issues at home, we have a whole team, a professional team that are dedicated to help you. In terms of your academic studies, you have one of me. You'll be assigned an academic in your department who will mentor you through your undergraduate studies. We've also then got the My Uni Hub, which is the online platform which helps you sort of with all your other like tuition fee payments, what you expect from your exams, any financial aid, any sort of visa application problems. That's all online as well. And there's some really good tools there that you can find. Okay, so go and have a look at them. If especially if you're an overseas student, you'll find a lot of information there on My Uni Hub. And not to harp on, but you know, you may as well play to your strengths. We have fantastic industrial interaction. It is one of the strengths of Swansea University. We work closely with industry. I've mentioned there we do a lot of site visits. We have a lot of guest speakers come, do evening seminars. Some of them also actually come into the modules and do guest lectures. We use industrial case studies in our teaching. A lot of our final year projects are sponsored by industrial partners. Some of our research projects are directly funded by them. So I'm running 2, one master's student and a PhD student who are directly funded by industry at the moment. And like I said, we pay a lot of attention to what our industrial partners say about you guys, about our students. If they turn on and say, oh, you know, they're academically they're very good, but their presentation skills aren't so good, and their written report isn't you know, their report writing skills aren't that strong, we then feed that back into our curriculum. So the students that we produce normally get snapped up pretty quick by the industry, because the industry have had a bit of a say in what they want. Okay, so you are well prepared then once you graduate for the industrial world. So as a result then your employability does go up quite a lot, which leads me nicely on to our statistics. Now, the College of Engineering as a whole has a 95% employability record, and that's not just in any old job. That's you guys getting employed within 6 months in a position that is related to your degree. For the materials department, that's actually a bit higher. Throughout the year, you'll have things like skills days, careers fairs, you have industrial visits, there's an employability newsletters. There's all sorts of support there for you guys getting employed after you leave. Okay, there's engineering skills days where you get to do like CV writing, practice your interview skills as well. So really well supported. So what can you do after you leave once you've been supported and you've got your CV and you've got a great interview? Like I mentioned earlier, you can work in any of these disciplines, the transport, materials manufacturing, medical industry, aerospace, defence. materials in sports, communication, energy is a big one at the moment, and structural civil engineering companies. They all want materials scientists. Okay, you can work in a lot of these fields. And these are just a handful of some of the companies that sponsor some of my projects at the moment. So one of my third year students, she's actually an aerospace student, but she's working with a company in Neath in South Wales that provide material for the European Space Agency. You can see there I've worked with Rolls-Royce and Tata Steel in the past, working on new generation alloys for Rolls-Royce, and working on sheet steel and electrical steels for Tata Steel. We work closely with Jaguar Land Rover, Airbus. I'm working on landing gear steel at the moment. So one of my third year students, she's working on the type of steel that they use for landing gear. We do a lot of work with the Royal Mint as well, Time Met, and the National Nuclear Laboratory, where we look at the different materials that they use for power generation. So, I mean, this list, I mean, I only put a handful on here. This list could have gone crazy with all the different sort of companies that you can work for afterwards. So I mentioned earlier the materials engineering department actually has a slightly higher employability stat. See, they're really proud of this. 97% of you will be employed within 6 months of graduating in a job that is related to your degree, where the starting salary will be £25,000 on average. Okay, which is really, really nice. Okay, normally within a couple of years, undergraduate students they sort of quickly outstrip the salaries of junior lecturers. Okay, so you normally do really well after you leave. Lastly, go online. Have a look at some of the link there, www.swansea.ac.uk/research. We, as a materials engineering department, have quite a small number of students per year. Your class size is between 30 to 50. 30 to 50. Which is really nice because it's quite a family feel. We get to know you as students, and you get to know us as lecturers. We do notice when you miss lectures as well, which is quite good. You don't, when you're teaching 200 to 300 people, you kind of become a faceless group mass in front of you when you're trying to teach that kind of group. But when you've got about 30 to 50, it's much more friendly. Okay, but the amount of research that we output as a department is huge. We're one of the smallest cohorts, but we actually bring in the biggest amount of research funding to the university. Okay, so I encourage you to look at some of our statistics online. We're one of the top 30 research universities in the UK. And we've got some fantastic world-leading research projects at the moment. You might have seen some of it in the news, where Swansea University is helping 3D print face masks and produce other support material for the NHS. So have a look on the link there and kind of see what we're up to. It's really fun. Here's the last couple of slides. Here's the stats. We're one of the top 10 universities for graduate prospects. We're quite affordable place to come and live as well. You can see there we're the third most affordable university. So if you're worried about that, then that's something to consider. I've already mentioned the Gold Teaching Excellence Award, and I think if you were to ask Hugh Summers, I think if you were to ask somebody from the head of the college, I think they would probably be most proud of winning the What Uni Student Choice Awards, University of the Year last year, because that's one of those awards that's not, it's come from you, it's come from the students voting for their favorite university, right? So winning that was actually fantastic. Last year as well, we were the Welsh University of the Year, and we were the Times Good University runner-up in 2019. So some brilliant stats there, and I think we should be really proud of that as well. The materials department itself, how does it fare to other materials departments in the UK? We're ranked top in Wales. We're the UK top 10 for student satisfaction and top 5 in the UK for career prospects. So if you want more information, you can go on the link at the bottom. And what will you expect to get? Just to summarize, you'd expect to have quite an interdisciplinary experience with great industrial links, fantastic student satisfaction, working on projects alongside world-leading researchers, and at the end of it you're going to have fantastic job prospects. So I hope I've given you an introduction to the department. If you want any information at all, then you can see my email is at the top, m.p.coleman@swansea.ac.uk. Thank you very much.